Okay, so the idea of the free body diagram is we have to draw the identified force, right? So for example, this page it says sliding without friction. So if it is sliding without friction, the force will slide this way, right? Force down plane. If it's on the incline, the force down plane, it slides this way. This vector force parallel to this one, right? And we have to identify the force G, which is the vector straightforward force G. And of course, there will be a force normal perpendicular to the surface. So all we do is draw whatever the identified force supposed to be, right? So the second one, static friction. In this case, because we have static friction, and static friction is prevent the rock is from falling down. So we have to draw the force G and the force normal just like this. But this time, because there is a force this way to hold on this drop, so keeping this drop not sliding forward. So therefore, instead of drawing the force down here, which is actually it's true, but we can omit this. We just have to draw the identified force this way because the force friction is the one who prevents the rock falling this way. Therefore, we draw this component, right, for friction. Okay. So
if we drew force down plane, like on the quiz, would we get a mark off?
I think in the quiz it show you already the A and B and C and D choice. So you will choose the best diagram, right? Yeah. Yeah. Yeah, so you choose the best diagram. So let's say they draw another one down here, but you wouldn't choose that. You might choose this one because we want to justify the identified force, right? So the identified force is, of course, this drop is sliding down this way, but however, there must be a force to hold it on the plane. So there is a friction force to keep it on the plane. And this is the force you want to draw, right? Okay, so that's the idea. You don't have to draw on the forces, you just draw the identified force. That is about the free body diagram. Okay, so even though the force is there, but you don't have to draw it, you just have to draw whatever the force we want to mention in the free body diagram. We just want to mention the force that affect the system or the force, so we just draw the identified force. Okay, so the identified force, for example, this one is say decelerated because of kinetic friction. So we know that this rock have to go back this way because the motion like this, right? But there's the force this way, it's for friction because say decelerating. So this force will make the drop slow down, and therefore this is the identified force for friction this way. Okay, so that's the idea. Now let's go through so that we have time, otherwise we'll not have time. Okay, we'll go through. Also, this one is the one you pay attention for the quiz, right? So you see that this we went through before. A woman at an airport is towing 20-kilogram suitcase, right? So we went through this question before. We did it, 2 questions here, right? So one case is no friction, and another case is half the friction, right? So in the case is no friction, you see that this suitcase was wrapped by an angle of 50-degree angle, right? So the question asks you to find force normal, draw a free body diagram. So this is what we draw, right? and then we say calculate the force normal. So the force normal, you pay attention to, in the case you have a force normal with the angle like that, right? If the box is straight like that and no angle, it means the force normal is the component straight like that, right? Usually it's the force normal in Fg. But because this one have an angle, so therefore the force normal is the force normal. If you draw this diagram, right? This force normal, because this force is acting in the horizontal composition, right? So the force, when it drops like that, when it drops at this angle like that, right? It means you have a two vector component. This you call it Fy, and this you call it Fx. And the force Fx is mg, mass of this, suitcase, times with the 9.8, times with cos 50 degrees, because that is the Fx, right? So Fx is this force, vector force is the force right here, right? Force right here, and this force is she pulled with 60 Newton. So the force Fx is 60 Newton times with cos 50 degrees. But force Fy will be 60 Newton times with sine 50 degrees, right? And therefore, in this case, the force normal will be equal, the force normal will be equal mg minus Fy, right? Will be equal the force mg here, but because she dropped it in a 50-degree angle to reduce the force, to pick the suitcase, to drop the suitcase, so instead the suitcase have to overcome the force of gravity, very heavy, but since she dropped it in the angle with the strap like that, so it reduced the force by the Fy component here. So therefore, to find the force normal, you subtract the Fy component here, which is mg sine theta minus, which is Fg minus mg sine 50 degrees. And therefore, you get this normal, right? So pay attention to this diagram, right? To know how you calculate the force normal, okay? Now, the second one, in this case, you do have a friction, right? So if in the case you have the friction, you calculate the force normal will be the same thing, mg minus Fy, which is you got the same 150 Newton. But because you have a friction, so your force net will be equal, force friction will be equal your force net minus force applied. So this is the case, okay? So you know that the force normal will be calculated by subtracting the Fy, because the Fy component here to help the suitcase, you don't have to use a heavy force to pull it, to lighter, to overcome the force gravity, right? And to make the suitcase lighter, so you don't have to put in a lot of force. So therefore, the force normal here will be reduced by the Fy component, okay? So that's the thing, you should pay attention to it. And you should know how to find the force normal by this diagram, right? So if there's a block on the incline, it asks you to draw the free body diagram. You should know you draw the Fg like that, and you draw the force normal perpendicular to the box like that. And the way you calculate the force normal will be this vector, right? This vector up And this vector is what? mg, which is this hypotenuse, mg times with cos theta. It will be always like that because this is the angle theta, and this angle theta is how much? 15 degrees. 15 degrees. So this vector component will be equal for the vector mg, which is 78.4 Newton here, times with cos of this angle theta. And that's the way you calculate the force normal when the box is sitting on the incline like that, right? Okay, so everybody remember this for your quiz, okay? So this block will be, the force normal here will be calculated based on this vector component, which is the adjacent. And because the adjacent over the angle, so we use the cos theta, we don't use sine. But the force vector, this one here, will be parallel to this vector. And we call this is the force down plane. And the force down plane calculated by opposite to the angle, so will be equal mg times sine 15 degrees. But the force normal will be mg times cos 15 degrees. Okay, everybody got it? Right? Okay, so pay attention to the free body diagram of the incline like that. Okay, so now let's go through this one, and I'm going to go through with you doing this right now here. Okay, and I hope that this video record. Okay, so I'm going to do the question 6a here. Okay, to finish today. Okay, so you have a sit-down student, one box sit on the inclined plane, and what? We are at here. We finished all of this already. We haven't done this question?
No.
5. You were at 6.
Yeah, okay, so we are at 6.
No.
No.
We haven't done 5? Oh, we haven't done 5. I thought we done 5 already. Okay, so then we do 5. Okay. Okay, so we're going to do 5. Okay, 2 blocks resting on a fictional surface are connected by a light rope of negligible mass. A horizontal force F equal 90 Newton. So this force is 90 Newton. Apply as shown, where M1 is 10 kilograms, so this one is 10 kilograms, and M2 is 15 kilograms. So this is M1, this is M2. Draw a free body diagram for each block. So we're going to draw a free body diagram now. There is a force Fg for this block, and there will be a force normal up against this, and they cancel out each other. This is force normal, and Fg will be equal 10 kilogram times with 9.8, which is 98 Newton. We're going to do M2 the same. There will be Fg, and this is 15 kilogram times with 9.8, and therefore the Fg for the second block will be equal how much? How much, students?
147.
Yeah, find out it.
147.
140. Is that right? Is FG2 equal what? 147 Newton. Okay. And therefore, the force normal will be the same, right? For this case. Now, so we draw this, determine the acceleration of the system and the tension T. Okay, so the acceleration of the system, and do it have the friction in here or no? Two blocks resting on a frictionless. So we don't have a friction in this case, right? And our force apply, whatever the force is the force pulling this two blocks to the side, to the right. It means our force net equal force applied in this case and equal 19 Newton. Okay. And therefore our acceleration will be equal force net divided by total mass. And our total mass is 90 Newton divided by how much? 15 at 25, okay. 25 kilograms. So the acceleration will be equal to 3.6 meters per second square. Is that right? You can check it by the calculator. Okay, so that is the acceleration of the system. Okay, determine the acceleration and the tension. Okay, so now we're gonna find the tension. So the tension, look at this factor, this string endure the mass of the second mass behind to wrap the mass M1 forward. So therefore, the tension will be equal mass of M1 times with the whole acceleration, right, of the whole system. So this vector have to wrap this one. Hello.
Lisa will have these out after school.
Yeah.
Okay.
Thank you. Yeah. So the mass of this one is 10 kilograms. Times with the acceleration will be equal 10 kilograms times with 3.6, which is equal 36 Newton. So the force tension here equal 36 Newton. Because it dropped the mass one, right, forward this one. So if you have more block this way, you have to add the total mass upon the block behind the string, okay? If you have more blocks, but we only have one block right here. So that's the force tension right here, okay? So now let's go to the next question. The next question is saying, Isaac, can you
Two
read
blocks
that?
connected by a light rail throw of negligible mass are being dragged with a horizontal force F. Suppose that F equals 90 newtons, M1 equals 10 kilograms, M2 equals 15 kilograms. Coefficient of friction between each block is 0.2.
Don't think it's this work. Not gonna work. Okay, how about Yeah, this camera goes there, but it doesn't work. It doesn't work. It's either one of this way. So I don't think I can record it actually. It doesn't point towards that, but it's here instead. No, we cannot record this. I don't know. It doesn't record that, but it records here, and so I have no idea. Okay, just whatever it is, just okay, let's finish this one first, and then I might have to go to the bar and do the other one, to record the other one. Okay. Somebody read it for me, Isaac, please.
Two blocks connected by a light rope connect negligible mass are being dragged by a horizontal force F. Suppose that F is 90 newtons, and M1 is 10 kilograms, M2 is 15 kilograms, and the coefficient of friction between each block and the surface is 0.2.
Okay, so now in this case, we don't have the for friction because we have a coefficient, right? So how do we calculate the force friction in this case?
Force F equals force F.
Force friction will be equal force normal times with mu, right? Force friction always equal force normal times mu. That's the formula. Okay, remember mu equal force friction divided by force net, right? So divide by force normal, sorry, not force net, but force normal. So if you pick this up, force normal times mu equal force friction, right? So now two blocks connected by light rope of a negligible mass are being grabbed by horizontal force. Suppose that force 90 Newton. So this is still 90 Newton mass, and the coefficient friction between each block and the surface is that. Draw a free body diagram for each block. So free body diagram same like this: FG, abnormal, FG, abnormal. Okay. Draw a free body diagram for each block. Now this time we do have a friction this way, so let's draw it for friction. Okay. Determine the acceleration of this system and the tensor. So the acceleration of system is the acceleration of system now have a force net. So A will be equal force net divided by total mass. And now force net will be equal force applied minus force friction. Because this time we do have a force friction over total mass. Okay. So our acceleration at this time, we have to calculate the force net. Now, the force tension is the one, the force friction equal force normal times mu, right? and we apply the force for this block. But there is a force of this block against the motion this way. So the acceleration here, yeah, so we have to find the force friction. Now the total mass is 25 kilogram, right? 25 kilogram times with 9.8, which is, and time with 0.2, that will be the force friction. So the total mass is 25 kilogram times with 9.8 times with the coefficient here 0.2. So the force friction here will be equal to 49 Newton. Is that right? You want to check that? Is that 49? So 25 times 9.8 times 0.2. Yeah, 29 Newton, right? So the force net will be equal 90 Newton minus force friction, which is 49 Newton, divided by total mass, which is 25 kilograms. So the acceleration will be equal 41 Newton divided by 25 kilograms equal 1.64 meter per second squared. So because now it have a friction, that's why the acceleration is slowed down. Instead of 3.6, it will be only 1.64. Okay? Does that make sense? All right. Now let's go to the next one. And I don't know if it's there or it's here, whatever. I should try not stopping, but I don't know if it will work or not. Okay, so somebody read for me. Mia, read the first 6A.
9 kilogram heavy mass measured by a string over 40 to 5 kilogram block that is being supplied on a flat frictional table.
So again, this is case one, no friction, right? No friction. So because it's no friction, this block sitting on this doing nothing, it no effect the system. The system affected by this block. So the block is going down this way. The acceleration downward this way. Let's make that as positive acceleration downward, right? This way. You see 9 kilograms times with 9.8. What is the FG of this one? FG is 88.2 Newton. Okay. So this block were pulling down by this block. The system were pulling down by the heavy one, 9 kilograms. This one is 5 kilograms, right? It's less. Also, it was sit on the table, do nothing. So the acceleration down this way, okay, 88.2 Newton. Find the acceleration of 5 kilogram mass. Now, this mass will be pulled down this way as well, right? With the same direction of motion. So the force normal, the force Fg for 5 kilogram will be 5 kilogram times 9.8. And 5 kilogram times 9.8 is how much? Oh, sorry, students. We don't have to worry about that because this is frictionless. Okay, so we don't have to. Okay, so the acceleration of 5 kilogram actually the same like this block is accelerate and pull it down. So the acceleration will be equal force net, which is 88.2 divided by total mass. Total mass. So 88.2 Newton divided by 9 at 14 kilograms. So that's the acceleration. And this acceleration equals 6.3 meter per second square.
Why do we use 14 kilograms and not 5 kilograms?
Because this block would make the string, because the string have to pull this one as well as this one down this way. So yes, we have to add the total mass for the whole system.
Take a little more this way, because the shadow from the thing is blocking.
Yeah, I try to adjust this on my screen here, but it seems it doesn't work. Because this camera is not recorded over there, it's recorded here instead, and here it didn't see anything, but I don't know. Anyway, it won't work. I think it won't work because that looks like it's recorded here instead of there. See here anyway. I don't know. I have to see the when after. Okay, so you guys see it, right? So find the acceleration of 5 kilograms. The acceleration is 6.3 meter per second square.
And that's the same for the other one too?
No, it won't be the same. Now find the tension in the string. Yeah, I mean the acceleration is the same for the whole system. Okay, find the tension in the string. So now we have to find the tension in the string. And remember the string have T1 here and T2 here, but T1 will be equal to T2 for the whole system. The tension in the string will be the same for the whole system. And to find the tension in the string, now you know that this force of gravity is going down, right? Pull this one down, but the force tension is pulling it up, right? You cannot see it?
Shadow blocking. That's good.
Okay, so the force tension here, T2, right? T1 equal T2 will be equal mass times acceleration. Mass M2 times acceleration, which is equal 9 kilograms times with 6.3 meter per second square will be equal 57.6 Newton.
Isn't acceleration of the second block different from the whole system?
It's for the whole system. The acceleration, the tension in the string for the whole system.
Yeah, but if we're talking about the acceleration of T2, we'd be looking at the acceleration of the second block. Is that different?
Yeah, we applied
The second block.
for the second block.
What we did was the acceleration was for the 5 kilogram mass.
For the 5 kilogram,
So would the acceleration be different for the 9 kilogram? Or would it be like 9.8?
now because this one had no friction, so we,
But what about gravity?
okay, give me 1 second. Let me check something. Okay, in the first problem, I just have to let you know that because we don't have friction here, so this block have no effect. And therefore, when we calculate the force tension, we use the second block and calculate it. And the tension for the second block will be the same like tension here. Because this block have no effect and we don't have a friction. But let's do the second one, you will see. Okay? I understand your question, but we're not gonna worry about that. How about if we go to the second problem and we see what is the difference between the force friction and no force friction, and then we will look at this. Okay? We'll go back to this. Okay? So the acceleration, the tension for the string here, and I said T1 will be equal to T2.
Yeah, I know that part. I'm just asking if the acceleration is 9.8.
The acceleration is 6.3. T2 is this tension string is the same like the string here.
Yeah, I'm not saying they're not the same. I'm saying to find it when you use the mass, you use mass to,
Of 9 kilogram, because this,
because that's what we're looking at. We have to see that factor of, and when the acceleration is 9.8, because the force of gravity is moving it downward.
so the force of tension here is the force of gravity, right? 88.2. And the acceleration go this way. The force tension here is M2 times with the acceleration theta. Because the acceleration is already going this way, right? And the acceleration is going this way, it means the same motion with the force of gravity, right? Okay, so it against the motion, the tension is against the motion, but also because the acceleration goes this way. So what is this answer? If you do 9 times 6.3, you get 57.6. That is the same component direction with the force of gravity, right? So now the string here, the acceleration go down this way. So the string here, it just have to endure whatever it is. This is a force net, allow this system acceleration downward, right? So this tension in the string, here is already overcome the force of gravity here so that it can move this block down. So this force tension, we have to, this force tension here, because this force is moving downward, right? moving downwards. So the acceleration is the same with the acceleration. This is the cause. This is the cause for this block causing it downward.
Attention grade 7 to 12 students. Please return to your homeroom. There is a handout before the end of school. Grade 7 to 12 students. Please return to your homeroom now. There is a handout before the end of school. Thank you.
Okay, we're not going to have time to finish this question, but you will be able to do the quiz tomorrow because the quiz will not include the last 4 questions here. The last 4 questions here will be help you to do the assignment. So the quiz is just about the tension in the string like this and how to find the normal force and things like that when it's on the incline or whatever. Okay. So these 4 questions here on the back as well will help you to do the assignment. Okay.